Okay, so for my project, I'm going to be using water and M&Ms. It doesn't matter how much water, it doesn't matter how many M&Ms. It's going to have the same effect. So all you do is just dump the M&Ms in this bowl real quick. And I'm just going to dump the water in the bowl. And what's going to happen is that you'll notice that the M&Ms will dissolve. It's because the molecules of the solid and the molecules of the liquid are attracted to each other. They're both polar molecules. Sucrose is a polar molecule, and water is a polar molecule. And as we notice, we can start seeing the dissolving now. But as we notice, it's just the coating and the coloring. The coating on the M&M is mostly sugar, so it's just the sugar that is dissolving, and the water is dissolving it because it is attracted to it. And because it's attracted to it because the sugar is made of ionic bonds. But what is actually happening here is the whole sucrose molecule breaks away from a whole nother sucrose molecule. So the individual atoms do not break off. But you'll notice that just the sugar and the coating is being dissolved. The chocolate inside the coating itself you can notice right here that the underlayer, the inner layer of the chocolate stays the same, because the chocolate is not a polar molecule. So that does not get dissolved. It just floats or sinks, I guess, in this case, because it's more dense than the water. You can see that, yeah. So what I mean by when I say the molecules are polar means that the sugar has a slight negative charge and a slight positive charge. So does the water. The water has oxygen and hydrogen, and hydrogen has a slight positive charge, and oxygen has a slight negative charge. And those two atoms are attracting the atoms of sugar. And that is what happens when you mix M&Ms with water.